There are two theorems about right triangles that are very useful in finding easily the lengths of its sides. We often call them as the special right triangles. The special right triangles are illustrated by these two figures. They are actually named based on the angles formed in the said triangle. The first one is named as 45-45-90 triangle. As you can see, the angles formed in the first triangle are 45 degrees, and 90 degrees. Since the two legs of this right triangle are also equal, we can also say that this triangle is an isosceles right triangle. The second triangle is named as 30 degrees, 60 degrees, 90 degrees triangle. That's because the three angles formed are 30 degrees, 60 degrees, and 90 degrees. If the side opposite of one of the 45-degree angles of the isosceles right triangle is 1 unit long, we can therefore say that the opposite side of the other 45-degree angle is also 1 unit long. From this, we can solve for the hypotenuse of the 45-45-90 triangle. That is by using the Pythagorean theorem. We then have the square of the hypotenuse is equal to the sum of the squares of the two legs. The hypotenuse is the unknown and the two legs are both 1 unit long. So we have the square of the hypotenuse is equal to the square of 1 plus the square of 1. The square of 1 is 1 and the square of the other one, of course, it's 1. Then, adding the two ones, we have 2. In order for us to find for the length of the hypotenuse, we need to extract the square roots of both sides of the equation. We have the square root of the square of the hypotenuse is equal to the hypotenuse. That's equal to the square root of 2 is square root of 2. That leads us to the 45-45-90 triangle theorem, which states that in a 45-45-90 triangle, the hypotenuse is square root of 2 times as long as each leg. From the given theorem, we can have this 45-45-90 triangle ratio. We have 45 degrees, 90 degrees, 1 is to 1 is to square root of 2, 1x is to 1x is to x square root of 2. As you can see on the figure, this 45-degree angle has the opposite side which is 1 unit long. 45-degree angle, its opposite side is 1 unit long. Another 45-degree angle, its opposite side is another 1 unit long. We have 45-degree angle, its opposite side is another 1 unit long. This is the right angle and its opposite side is 2 units long. We have 90-degree angle, its opposite side is square root of 2 units long. Please always take note that in the ratio 1x is to 1x is to x square root of 2, your x is the side opposite 45 degrees. Triangle GOD is a 45-45-90 triangle. Find the lengths of segment GO and segment OD if the length of segment GD is 5 units long. From the given problem, we can have the ratio segment GD is to segment OD is to segment GO. As you can see, segment GD is the side opposite of one of the 45-degree angles. Another side opposite of a 45-degree angle is segment OD. And your segment OG is the side opposite the largest angle. That's why your segment OG is called the hypotenuse. We can then have the ratio 1x is to 1x is to x square root of 2. This is based on the 45-45-90 triangle. Please always take note that x is always the side opposite 45 degrees. In the given, segment GD is 5 units and its opposite angle is 45-degree angle. Therefore, the value of x then is equal to 5. And it's also given in the problem that segment GD is 5 units, and segment OD, for segment OD, we have 1 times the value of x is 5, that is still equal to 5. For segment GO, we have x is 5, then times square root of 2, we have 5 square root of 2 for segment GO. We then have segment GO is once again 5 square root of 2 units, while for segment OD is 5 units. Triangle USL is a 45-45-90 triangle. Find the lengths of segment UL and segment SL if the length of segment US is 7 units long. As you can see, the given is the hypotenuse, which is 7 units long, and that is your segment US. Since the hypotenuse is the opposite side of the largest angle, therefore we don't have any value of x yet. We solve first for the value of x. We solve for the value of x using the given, which is segment US is 7 units long. Since segment US is the hypotenuse, and in the 45-45-90 triangle ratio, the hypotenuse is x square root of 2. We then have x square root of 2 is equal to your hypotenuse, which is 7. In order for us to find for the value of x, we need to divide both sides of the equation by square root of 2. So x square root of 2 divided by square root of 2 is x, and 7 over square root of 2 is still 7 over square root of 2. Since radical expressions are not simplified if the denominators have radical signs, we need to rationalize the denominator of 7 over square root of 2. That is just by multiplying square root of 2 to both numerator and denominator. So 7 times square root of 2 is 7 square root of 2, and square root of 2 times square root of 2 for the denominators is equal to square root of 4. Since square root of 4 is not yet simplified, we then have our answer as 7 square root of 2 all over 2, and that is now the value of x. Since we are now done solving for the value of x, we are now ready to solve for the lengths of segment UL and segment SL. In the 45-45-90 triangle ratio, we have segment UL is to segment SL is to segment US. That is 1x is to 1x is to x square root of 2. Since we are given the hypotenuse, which is segment US, and that is 7 units long, we don't need anymore to solve for the hypotenuse. We have the value of x is 7 square root of 2 over 2. By substitution, we have 1 times 7 square root of 2 all over 2 is equal to 7 square root of 2 all over 2, and that is the length of segment UL. The same is true with the length of segment SL. So the length of segment UL is 7 square root of 2 all over 2. The same is true with segment SL, which is 7 square root of 2 all over 2 also. The 30-60-90 triangle theorem states that in a 30-60-90 triangle, the hypotenuse is twice as long as the shorter leg, and the longer leg is square root of 3 times as long as the shorter leg. This shorter leg and longer leg that we are referring to here in the 30-60-90 triangle are the following. The shorter leg is the side opposite the 30-degree angle, and the longer leg is the side opposite the 60-degree angle. And your hypotenuse is always the opposite side of the largest angle or the right angle. From the given theorem, we can have this triangle ratio. We have 1 is to square root of 3 is to 2, or 1x is to x square root of 3 is to 2x. Please take note that your 1 here is the shorter leg, square root of 3 is the longer leg, and 2 is the hypotenuse. 1x is the shorter leg, x square root of 3 is the longer leg, and 2x is the hypotenuse. Please always take note also that your x is the side opposite 30 degrees, or in other words, your x is the shorter leg. Triangle QPC is a 30, 60, 90 triangle. Find the lengths of segment QC and segment PC if the length of segment QP is 12 units. Based on the figure, we can have this ratio, which is segment QP is to segment PC is to segment QC, or in other words, we have shorter leg is to longer leg is to hypotenuse. That's based on the given. Segment QP is the shorter leg, segment PC is the longer leg, and segment QC is the hypotenuse. Therefore, we have 1x is to x square root of 3 is to 2x. Always take note that x is always the side opposite your 30 degrees. As you can see on the figure or on the given, the side opposite 30 degrees is segment QP, which is the given, and that is 12 units long. Therefore, we can say that x now is equal to 12. So, based on the given, we have segment QP is 12 units long. So, since x now is equal to 12, by substitution, we have segment PC x square root of 3, that is 12 times square root of 3, and still that is 12 square root of 3. For segment QC, we have 2x. 2 times the value of x is 12. 2 times 12 is 24. Therefore, segment QC now is equal to 24 units, and segment PC is equal to 12 square root of 3 units. Triangle EDC is a 30, 60, 90 triangle. Find the lengths of segment ED and segment EC if the length of segment DC is 5 units. Based on the given, segment DC is the longer leg. Therefore, we need first solve for the value of x. In a 30, 60, 90 triangle ratio, the longer leg is actually equal to x square root of 3. Since segment DC is the given and that is the longer leg, which is 5 units long, we can have the equation x square root of 3 is equal to 5. Dividing both sides of the equation by square root of 3 in order for us to have x on the left side of the equation, we have x is now equal to 5 over square root of 3. Since 5 over square root of 3 is not yet simplified, we therefore rationalize the denominator since the denominator still has a radical sign. That is, by multiplying both numerator and denominator by square root of 3. So 5 times square root of 3 is equal to 5 square root of 3, and square root of 3 times square root of 3 is equal to square root of 9. And 9 is still a perfect square number. Therefore, our final answer would be 5 square root of 3 all over 3. That is now our value of x. We are now ready to solve for the lengths of segment ED and segment EC since the value of x is already solved, which is 5 square root of 3 all over 3. We can solve this by using the 30, 60, 90 triangle ratio, which is shorter leg is to longer leg is to hypotenuse. Segment ED, based on the given, is the shorter leg, segment DC is the longer leg, and segment EC is the hypotenuse. That is 1x is to x square root of 3 is to 2x. So since we are given segment DC as 5 units, we can now say that segment DC is 5 units on the ratio. If the value of x is 5 square root of 3 all over 3, by substitution, we have 1 times 5 square root of 3 all over 3, and the product would be the length of segment ED, which is 5 square root of 3 all over 3. For segment EC, all we need to do is to multiply the value of x by 2. That is 2 times 5 square root of 3 all over 3. So 2 times the quantity of 5 times square root of 3 all over 3 would be 10 square root of 3 all over 3. That would be the length of segment EC. So the length of segment ED is 5 square root of 3 all over 3, while the length of segment EC is 10 square root of 3 all over 3. Triangle XYZ is another 30, 60, 90 triangle. Find the length of segment XY and segment YZ if the length of segment XZ is 16. Segment XZ, based on the given figure, is the opposite side of the largest angle. Therefore, segment XZ is the hypotenuse. And in the 30, 60, 90 triangle ratio, the hypotenuse is equal to 2x. Therefore, we have 2x is equal to the length of the hypotenuse, which is 16. Dividing both sides of the equation by 2, the value of x would be 8. If the value of x is 8, then we are now ready to solve for the length of segment xy and the length of segment yz. That is, just by using this ratio, segment xy, the shorter leg, is to the longer leg, segment yz, is to the hypotenuse, which is segment xz. That is, 1x is to x square root of 3 is to 2x. Based on the given, the hypotenuse is 16. That's why segment xz is 16. We now solve for the length of segment xy. That is, 1 times the value of x is 8. That is equal to 8. For the length of segment yz, that is, x is 8 square root of 3. Therefore, the length of segment YZ is 8 square root of 3.